Next is a complex low pass representation of band pass signal. Let us consider a time invariant band pass signal with an impulse response h of t and its frequency response we can call it as h of t as in the h of f only. That is considered in a LTI band pass system. H of t with an input of s of t will get an output. Consider and here a narrowband signal s of t with its Hilbert transform. We can write it as a s of f, and we assume that the spectrum of the signal s of t is limited to the frequency omega to plus or minus omega hertz in the carrier frequency fc. Therefore here we can call it as a signal bandwidth is 2 times of omega, and the system bandwidth you can call it as a 2 types of bandwidth. Usually 2b is approximately equal to the 2 omega, where here h of t represents, that is the impulse response represents the in phase and the quadrature phase, that is hi of t and hq of t. We can write an equation that is similar what we can written in the s of t, that is a band pass signal. Here it is an impulse response of a band pass system. Therefore h of t we consider as a hi of t hi of t into cos 2 pi fct minus hq of t into sin 2 pi fct. We can call it as equation 1, where consider h tilde of t is a complex impulse response of a band pass signal. For that we can written as a h tilde of t is equals to h plus of t plus j where here h tilde of t we can call it as a complex impulse response of the band pass signal. That is we define it like this, that is h tilde of t is equals to hi of t plus j hq of t, and h of t we can call it as an here only the real terms, that is h of t in terms of h tilde of t is in terms of h tilde of t is real terms of h tilde of t into e to the power of j 2 pi fct, where here hi of t, hq of t and h tilde of t are the low pass function. Consider h tilde of t is equals to hi of t plus j hq of t, and we obtain the complex conjugate as h tilde of t is equals to hi of t. Here that is a plus step. For complex conjugate we will get the minus hq of t, and we know that the h of t is equals to real terms of h of t into e to the power of j 2 pi fct. Using this equation let us perform this, that is if we add these two, that is complex conjugate with terms of the h of t, we will get the, that is h cap of t, h tilde of t into e to the power of j 2 pi fct plus h tilde of t conjugate of t into e to the power of minus j 2 pi fct. If we multiply this signal, that is, and we know that the h tilde of t can be written as hi of t plus j hq of t into e to the power of j 2 pi fct plus h tilde of conjugate. Here you can represent it as a hi of t, and here imaginary parts is there, therefore it is a minus because of conjugate, minus j hq of t into e to the power of j 2 pi fct. And if we multiply this and split the e to the power of j 2 pi fct, we will get the cos 2 pi fct plus j sin 2 pi fct. For here also we can split, that is e to the power of minus j 2 pi fct can be written as cos 2 pi fct minus j sin 2 pi fct. And if we multiply the signal, we will get, if we multiply and add the signal, we will get 2 times of, that is 2 into hi of t into cos 2 pi fct minus 2 hq of t into sin 2 pi fct, where if we take 2 as a common here, the remaining terms is hi of t into cos 2 pi fct minus hq of t into sin 2 pi fct. The remaining terms are only, we can call this as a similar like an h of t only. Whatever we define the equation 1, we know h of t is a hi of t into cos 2 pi fct minus hq of t sin 2 pi fct. So directly we can write it as a 2 into h of t, Therefore, we can write this equation 2 into h of t is equals to the h tilde of t into e to the power of j, and that is this equation is 2 into h of t we can is equals to h tilde of t into e to the power of j 2 pi f c t plus h tilde of conjugate of t into e to the power of j 2 pi fc of t. If we apply Fourier transform to the above equation, we will get to h of t can be written as a h of f, where h tilde of t can into e to the power of j 2 pi fct, we can write this as a f minus fc. For in Fourier transform, e to the power we will get the f minus fc. Therefore, h tilde of f minus fc plus h tilde of conjugate of here, the t can be changes into again for the e to the power of minus j 2 pi fct can be written as minus f minus fc. We know that the complex conjugate function, that is x of t, we can for a Fourier transform we get an x of f, and x conjugate of t can be written as x conjugate into wherever t is j, it changes to f. For conjugate we will get a minus f. This is applied to this only. By considering only the positive frequencies, we can refer this is considering only positive frequency. This is for positive and this is for negative. We will write we can write h tilde of t into f minus fc is equals to 2 into h of f. For h of f we want to write means 1 by 2 h tilde of t into f minus fc. This property, and we can write it as an, that is h tilde of t, h of t defined for only the positive frequency, where shifted it to the origin, that is f minus f is shifted into the origin, and scaling with a factor of 2, where the complex frequency response we can write it as the same here, that is h tilde of f is equals to, we know that the, because this is a time domain signal, where here we can write it in the frequency domain signal, h tilde of f plus j hq of t into f. This is f, when for the h I of tilde h I tilde of f can be written as, say directly 1 by 2 here h tilde of f minus h of f plus h tilde of conjugate of minus f. For the quadrature signal, h of f function we can written as a 1 by 2 h tilde of f minus j h tilde of conjugate of minus f, and if we apply inverse Fourier transform, we will get h tilde of t is equals to, integral varies from minus infinity to plus infinity, h tilde of t into e to the power of j 2 pi by fct with function d of f only.